So let's walk through this question together. And really the focus isn't necessarily figuring out, did you get it right? Did you get it wrong? I really want to focus on the process here. So let's go ahead and pull up my Triple T document, Tom's testing tips for the math section. And notice we have these 4 steps that really apply in every multiple choice scenario. However, because this is a student produced response question, we're going to go ahead and look at tip 2 here, which is really key in getting the mindset correct. So notice we say, if you don't know what to do to get the final answer right away, do something. Why? Because you know more than you think you do. So if you weren't sure what to do, take a look at your paper right now. Did you do a sketch? If you did, good for you. So let's plot -6,1 in the second quadrant and 7,12 in the first quadrant. Doesn't have to be extremely accurate. I'm just putting them in their respective quadrants. And then we know that -6,1 is the center. So I'm going to go ahead and do a sketch of my circle revolving around that center point. Your circle probably looks a little bit better than mine, so no judgment there. Let's go ahead and look at these 3 questions that really help you solve not only any math question, and not to get too philosophical on us here, but it really helps you to figure out the solution to any problem that you ever encounter. So it's very simple, just not easy. Let's take them one by one. So first, what is the goal? Well, we know it was to find the radius. Well, what even is a radius? So let's pause for a moment and see if you can explain what is a radius. Now, if you said, oh, it's half the circle or half the diameter, which is a very common answer that we get, think instead about the radius as its own identity, instead of being in the shadow of either the diameter or just saying half the circle. What really is a radius? Well, it's the distance from the center to any point on the circle. And in this case, they gave us the point 712 and the center. So I'll go ahead and connect those so we have a visual of the radius. So for the second question, what do I know? In other words, what were we given? Well, we were given 2 points that we then connected to show the radius. And finally, how do I get to the solution? Well, when they say find the radius, they're really saying what is the length of the radius? And a synonym for length is distance. So we need to find the distance between those 2 points. And you might be thinking, oh, I know there's a formula for this. How do I find a distance between 2 points? Or how do I find the radius? So if you go to the math reference document up here, which is what you're provided on the actual test, you might be thinking, oh, I know area is pi r squared, but that's not going to work because you can only have one unknown, right? You can't find the radius if you don't know the area. And really, we don't have a formula on here that explicitly gives you the distance. So let's go ahead and derive it really quickly. So let's say we look at the horizontal and vertical components here, and notice that forms a right triangle. And you might be thinking, well, with right triangles, I know there's this theorem that relates the lengths of the 3 sides. And you'd be thinking correctly, it's Pythagorean theorem, which is a squared plus b squared equals c squared. And in this case, which of those 3 legs is the radius? Well, it's the hypotenuse. I'm going to label that with an R here. Now, whenever we're trying to find the length of this horizontal leg, we're really finding the difference of the x coordinates. So we're going to call that x2 minus x1. And for the vertical leg, we're really finding the difference of the y coordinates. So let's say y2 minus y1. Now let's go ahead and rewrite Pythagorean theorem, which was a squared plus b squared equals c squared, but only using these variables. So we're going to say x2 minus x1 squared plus y2 minus y1 squared is equal to the radius squared, in other words, the hypotenuse squared. Well, we want to get the radius by itself. So how do we get rid of a square? Well, we square root both sides. And keep in mind that the radius is the distance between the center point and any point on the circle. So I'm going to go ahead and replace the r with a d for distance. Well, look at that. We just derived the distance formula. So if that looks familiar, good. If it doesn't, don't get too attached to it because I'm going to show you a more efficient approach in just a moment. But let's say you knew the distance formula right away. Let's look at how long it would take to find the distance between these 2 points if we were doing it by hand and with our calculator, including Desmos. So let's see how long it would take me, a mathematician, to get this answer if I go at a really steady pace from the beginning. So I would likely write the formula if I recognized right away I need to do this. And I'm going to go ahead and find the difference of the x's in either order. And I don't even have to keep the order the same when I do the y's, unlike with slope. And so let's say I'm really good at my mental math. I don't even need my calculator yet, so I'm not slowing down. And I even know my perfect squares. So I'm saving as much time as possible. And then I get to the point where I see root 290. Well, I'm still going to use my calculator in this case. So I'm gonna go here, type in SQRT to do a square root, and I see that my answer is about 17. And notice it took me around 50 seconds. So pretty good, right? For a level medium question like this, we really want to stay under a minute so that we have enough time for those level hard questions. Now, whether you get it right or wrong, I want you to notice how I'm going to do it in this attempt in a way more efficient approach. And I want you to see if this would be something that you would now be able to apply in the future. I'm going to go to Desmos. So let's go ahead and start that stopwatch. I'm going to type in these two ordered pairs, which you probably knew how to do on Desmos, but then notice this command. How long did it take me to get my answer? Less than 10 seconds? It's amazing, right? So there are things we can do on Desmos that most students never discover because no one's ever trained them in it. And that's what real test taking strategy is about. Not just knowing how to grind through the math by hand, but knowing when and how to conserve time and energy so you have more of both left for the hardest questions. Now, a lot of people talk about time management. And yes, saving a minute here or there is important, but what almost no one talks about is conserving mental bandwidth. Your focus, energy, and motivation are finite. If you burn too much of it on medium level questions like this one, you'll have less left in the tank when the truly difficult ones appear. And those are the questions that carry the most points and really separate the 1500s from the 1200s. That shift in mindset is critical. Here's another misconception we see all the time. Students, and even some tutors, believe you should only practice the areas where you got it wrong. But think about this example. If you solved it correctly using the distance formula, you might never be shown the faster, more efficient Desmos technique. You'd walk in a test day missing a powerful tool simply because you happened to get the question right. That's why at Zara Tutoring, we don't just patch weak spots. We systematically cover all 36 math themes and all 20 reading and writing themes. And for each one, we train you in the most efficient strategies. So you build a complete toolkit. That's what makes the difference between plateauing at 1,000, 1,100, or 1,200 versus climbing to 1,300, 1,400, 1,500, and beyond. And remember, you got this.